So in this video, we're going to look at how to find the highest common factor of simple numbers and then how to find the highest common factor of slightly more difficult numbers. So let's make a start. The way my videos work, I'm going to do the example on the left, which is I do. You're then going to press pause and have a go at the example on the right, which is you do. So question 1, how to find the highest common factor of 4 and 12. Firstly, what does HCF mean? H is the highest, C is common, so common just means the same, and factor is all the numbers that it's divisible by. So for example, the factors of 4 and 12, if you list them out, the factors of 4 would be 1, 2, 3 isn't a factor of 4 because if you divide it by 3, you'll end up with a remainder, and 4 itself. Now the factors of 12 would be 1, 2, it's also divisible by 2, it's divisible by 3, it's divisible by 4, it's not divisible by 5, it's divisible by 6, 7, 8, 9, 10, 11, and then 12 finally. So these are all the numbers 12 is divisible by without leaving a remainder. So now if you look at the highest common, so the highest common factor in both of them is going to be 4. So our answer here is 4. Now press pause and have a go at the example on the right. When you're ready, press play. So hopefully you went in the exact same way, listed out the factors of 6. So that would be 1, 2, 3, 4 isn't 1, 5 isn't 1, 6. And notice we stop at the number that we start with, which is 6. So again here, in this case, you would stop at 9, start at 1. 1 is 2, 3, 4, 5, 6. Yep, so in this case, it'll be 1, 3, and 9. So the highest common factor is going to be 3 in this case. Let's have a look at another example. So here we've got 10 and 15. Again, exact same way. I'm going to list out the factors of 10. So that's all the numbers 10 is divisible by without leaving a remainder. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So that's all the factors of 10. And for 15, so that's going to be 1, 2, so we have 3, 5, and 15. So the highest common factor here is going to be 5. And hopefully you've pressed pause and had a go at this one. So exact same way, list out all the factors. So 1, 2, 3, 4, 5, 6. And then 12 finally. And again, 1, 2, 3 might be 1, 4 is 5 is 6, 7, 8, 9, 10 is 1 as well. And then it would be 20. So the highest common factor here is going to be, let's see, 4. So 4 is the highest common factor there. Now here's some practice questions for you to have a go at. Press pause and have a go before we move on to slightly harder examples. So here's the answers, mark your work. So hopefully you found that C and D were slightly trickier to find than A and B. So I'm going to show you another way to find the highest common factor. And the way we do that is using prime factors. Now I've got a separate video on product of primes and how we use that to find the HCF. So what are product of primes? I should probably address that first before going into it. So a prime number is any number that is greater than 1, that is divisible by itself and 1. So for example, 2 is a prime number because it's divisible by itself and 1. 3 is a prime number. 4 is not a prime number because 4 is divisible by itself. 1, which is right, but it's also divisible by 2. That is why it's not a prime number. 5 is a prime number. 6 is not a prime number because even though it's divisible by itself and 1, it's also divisible by 3. 7 is a prime number. 8 isn't 1. 9 isn't 1. 10 isn't 1. And 11 is 1 and so on. Okay, so we're going to draw out the factor tree for 24. And we're going to draw out the factor tree for 40. So what two numbers do I multiply to give 24? 2 and 12. Every time you have a prime number, you circle it. So we're going to circle that 2 there. 2 and 6 gives us 12. Again, circle the prime number. And finally, 2 and 3 give us 6. So 24 as a product of these prime numbers is going to be 2 times 2 times 2 times 3. I do like to write these in order from smallest to biggest. And for 40, we can do 4 times 10 gives us 40. None of them are prime numbers, so we can break them down further. There we go. 2 and 2 is a prime number. And this can be 2 and 5. 5 is prime and 2 is prime, so we circle that. Again, write the product of primes of 40. again, I like to write these in order, so that'll be 2 times 2 times 2 times 5. And now you look for matching pairs. So this and this match, so that's one matching pair. This and this match, and this match. Now you just multiply the matching pairs. So remember I said pairs, so it's going to be 2 times 2 times 2. So the highest common factor of these two is going to be 2 times 2, which is 4, and 4 times 2, which is 8. So this is another method that we can use to find the highest common factor, rather than listing out all the factors. And you'll see why we use this when we move on to slightly trickier examples. So here we've got 36 and 54, which is a good example of a tricky one. So hopefully you've pressed pause and had a go at this one. So 36 and 54. So there's many ways you can go about doing this, but one way I can do it is 6 and 6, for example. You could have used 2 and 18, but 6 and 6 gives us that. And then that's going to be 2 and 3, which are both prime numbers. That's going to give me 2 and 3, which are both prime numbers. Again, I like to write these in order from smallest to biggest. I'm going to write 2 times 2 times 3 times 3. And then we have 54. Now, it's an even number, so we can just go with the 2 times table. So we've got 2 and 27. That can be 3 times 9. And remember to circle your prime numbers, and that's going to be 3 and 3. So 54 as a product of its prime factors is going to be 2 times 3 times 3 times 3. And now we're going to look for matching pairs. So that's 2 and 2 there, that 3 and 3 there, and that 3 and that 3 there. Multiply the pairs together, so that's going to be 2 times 3 times 3. 3 times 3 is 9. 9 times 2 is 18. So the HCF here is 18. Moving on, so we've now got 60 and 96. So again, the exact same way, if we're going to list out the product of primes and use that to find the HCF. So in this case, that's going to be 6 and 10. 3 and 2. Every time there's a prime number, we circle it. 5 and 2 there. So for 60, that's going to be 2 times 2 times 3 times 5. And for 96, that's going to be 3 and 32. So that's going to be 2 times 16. Circle that, and that is going to be 2 times 8. And that can be 4 times 2. And that can be 2 times 2. Okay, there was a lot to do there. A lot more than the other ones. Again, I like to write these in order because it just makes it easier when I have to pair them up. 2 times 2 times 2 times 3. So now we're going to look for matching pairs. So that's going to be 2 and 2, that 2 and 2 there, and that 3 and 3. So the HCF here is going to be 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. And again, hopefully you've pressed pause and had a go at this one. So we've got 75 and 90. So with 75, you can go with the 5 times table, 5 and 15. That's prime, so we circle it. That's going to be 5 times 3. And those are all prime numbers. So that for 75, as a product of its primes, is going to be 5 times 5 times 3. And 90, we can go with 9 and 10. 9 can be 3 and 3. That can be 5 and 2 to give us 10. And if you write 90 out, so that is going to be 2 times 3 times 3 times 5. And if I just highlight the matching pair, so that's going to be 3 and 3, and that 5 and that 5. So it looks like the HCF is going to be 3 times 5, which is 15. So we have now got 120 and 150. So again, when you're not sure what the number is divisible by, one way you can always think of it is it an even number? Yes, it is. If it's even, you can always divide it by 2. So we can go 2 and 60. Again, 60 is an even number, so you could have either gone 6 and 10, or you could just go, it's an even number, we can go 2 and 30 again. 30 is an even number, you can go 2 and 15. Now 15 is not an even number, but 15 can be 5 times 3, 3 times 5. So 120 becomes 2 times 2 times 2 times 3 times 5. And then we have 150. So for 150, we could go 10 and 15. Again, you could have gone down the even route as well, but it's really up to you what way you go. And 15 is going to be 5 and 3. So that gives me 2 times 3 times 5 times 5. Look for matching pairs. That's 2 and 2 there, and 3 and 3 there, and 5 and 5 there. So the HCF here becomes 2 times 3 times 5. Now 3 times 5 is 15. 15 times 2 is 60. Sorry, 30. 15 times 2 is 30. So then we have 32 and 80. Hopefully you've pressed pause and had a go at this one. So we have 32 and 80. That is going to be 4 and 8. That is going to be 2 and 2. That's 4 and 2. Again, circle the prime numbers. That's 2 and 2 there. So for 32, that becomes 2 times 2 times 2 times 2 times 2. Okay, that is a lot of 2's. And for 80, you can go with 8 and 10. 10 becomes 5 and 2, which are both prime. That can become 4 and 2. And that can become 2 and 2. So that leaves us with 80. And if you look for matching pairs, so that's going to be that 2 and that 2, that 2 and that 2, that 2 and that 2, that 2 and that 2. So the HCF here becomes 2 times 2 times 2 times 2. And that is going to be 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So that's going to become 16 there. Now here's some practice questions for you to have a go at. Please press pause and have a go. When you're ready, press play for the answers. So here are the answers. Mark your work. And that is the end of the video. So in this video, we've covered how to find the highest common factor of simple numbers and slightly harder examples, slightly harder numbers using product of primes. If you found this video useful, please consider subscribing to my channel, as I've got loads more content like this covering GCSE Maths. And as always, I'll catch you in the next one.